Hello class, today's practice problem is for chapter 15 on monopolies, and the problem that I want to work here is question number 4 from the end of chapter 15. You'll find this on page 315 of your textbook. This is a hard one. I picked this problem because there's a lot of different ideas that we need to be able to put together to navigate to the correct answer. So let's get right to it. Again, the best thing to do, hit pause on this little video here right now, give the problem a try on your own, and then you can see my analysis and then make sure that we're on the same page, you're understanding that everything that I'm doing, or maybe you have a different idea about something. That's, I think, a good way to go about it. All right, so if you're ready, let's get to it. Like I said, problem number 4 starts off with the description here where you're going to have a company that's thinking about building a bridge. Problem tells us that this bridge here is going to cost $2 million, and it costs nothing to maintain. So straight away, we're getting some information there. It's saying it's a $2 million upfront cost. That can be viewed as a fixed cost for this firm. It doesn't go up or down depending upon usage of the bridge. So $2 million upfront. And then the second part of that, which is telling us that there's no costs to maintain the bridge, that can be used to say something about the firm's marginal cost here. So it doesn't cost any more to this company regardless of how many people are using the bridge or how many people cross or however you want to frame it. So that means that the marginal cost is 0. Right? So I've constructed here a marginal cost column. I'm going to go ahead and fill this in with zeros all the way down. 1, 2, 3, 4, 5, 6, 7, 9. There we go. So we're on our way. Really the practice that we're going to use is going to be at first here to glean all the information that we need from the problem and then start applying economics that we know. Okay. So the other thing that we've got here on the board, I've got some numbers already filled in here. This is just replicating the table that's given to you. That table is showing you the anticipated demand for the bridge over the lifetime of that bridge. So different prices that they charge for crossings is going to show you how many people want to cross this bridge. And these numbers here are denominated in thousands. Okay. So I think that's all for the setup. Let's turn on lots of setup, right? Let's turn now here to the actual questions that are being asked to us. Question A reads, if the company were to build this bridge, what would be its profit maximizing price? And would that be an efficient level of output? Why or why not? Okay, so really this is asking you, how do monopolies go about deciding what price to charge? The principle that you want to apply is to find the one level of output here, 200 crossings, 400 crossings, 600 crossings, where marginal revenue is equal to marginal cost. It's a super handy rule. You've seen this in earlier videos and read about this a whole bunch, I'm sure. All right, so we want to find at which point does marginal revenue equal marginal cost. That'll show us the quantity that they should produce. Then we'll find the price that gives us that. Okay. So marginal cost we've already got, that's 0 throughout. We've got to figure out what the marginal revenue is. Okay, so marginal revenue, keep in mind, that's the extra revenue that a firm gets when selling one more unit. The change in their total revenue associated with a 1 unit increase in the quantity. All right, so let's first figure out the total revenue for all these different possible quantities, and then from the numbers in this column here, we'll be able to infer the marginal revenue. Okay. So total revenue for our company, that's the money they're receiving without saying anything about cost. You find that by simply multiplying the price by the quantity. So we're just going to multiply across these columns to get total revenue. See if I can do this without making any math errors here on the video. 8 times 0 means $0 of revenue. And then after that, we should have some easy math to work with. This should be 7 times 100 units for $700 of revenue, and then $1,200 of revenue, and $1,500 of revenue, and so on. So notice that as they sell more trips across the bridge, their revenue is rising at first. It's going to be peaked right here at a price of 4, quantity of 400. That gives us $1,600 of revenue, and then $1,500, and $1,200 again. It starts to fall once again. 700. Okay, so there you go. First step is to figure out the total revenue for each possible price that they might charge. Okay. Once again, the reason why we're doing that is because we want to say something about marginal revenue. Okay. Problem here is a little bit trickier in that we don't have 1 unit increases in these quantities. So we can't just compare 0 and 700 or 700 and 1200 because the quantity is going up by 100 in each case. So keep in mind then that the marginal revenue for a firm is going to be the change in their total revenue divided by the change in their quantity. Okay, so with that in mind, we can fill in the rest of these here. Impossible to do for the very first unit, but beyond that, we can calculate this pretty easily. So let's see here, starting for the first 100 units, right? They sell 100 more units. That's going to be the change in quantity. Let's do this first one. I'll write it out for this first one, and the rest we'll do in our head. So for first, that change in quantity is 0 up to 100. That's 100 more units being sold. And when they did that, their revenue went up by 700. So the marginal revenue then for this particular cell should be 700 over 100. Again, what you want to do for all of these is figure out how different is the total revenue. That's going to go in the numerator. And divide that by how different the quantities are, the change in the quantity. So then going here to our next one, you get $500 more of revenue, going from 700 to 1200. And that's associated with selling 100 more units as you go from selling 100 crossings to 200 crossings. So we then have 500 divided by 100 for a marginal revenue of 5. That's the practice we're going to use throughout here, filling out the rest of these. So then I can just sort of eyeball it for the rest of these. You should be able to do this too. I'll go a little bit more quickly. That's going to be 3, and 1, and -1, and -3, and -5, and -7. So our marginal revenue column then should look just like so. And this is really the critical one that we want to look at. Okay. So back to the question that's being asked to us in A. What price should this firm charge? Well, they want to sell all those units where marginal revenue is higher than marginal cost. Stop at that spot. Okay, so for the first 100 crossings, the marginal revenue is going to be $7 per crossing. They should do it. Marginal revenue is higher than that marginal cost. 7 is greater than 0. Keep going. Up until we get to this spot right here. This is where this monopoly wants to stop. Right? Because beyond that, the marginal revenue is now less than their marginal cost. Therefore, answer choice A. The question is, what price should they charge? Well, the one that's going to give us this particular level of output is a price of 4. If the firm were profit maximizing, they would decide on their own to choose that price of $4 per crossing. Okay. Would this be efficient? Right? To judge that question, what you want to do is weigh the marginal benefit to society versus the marginal cost. And we can see that these are both most definitely not the same. Right? The marginal benefit to the person crossing that bridge is significantly higher. They're willing to pay a price of 4 for that last unit. It's only costing this company, it's not costing them anything to produce another unit of the good. So the marginal benefit to the user is much higher than the marginal cost to the firm. So we're not at an efficient level. This is not efficient. That's actually a theme, right, that we see throughout our monopoly analysis, that left to their own devices, monopolies typically won't leave us with efficient outcomes. All right. On to question B. Question B is reading, if this company is interested in maximizing their profit, should it build the bridge? What would be its profit or its loss? Okay. A way to think about this question is to figure out if this company does as well as they can, which takes place when they're charging a price of 4 like we just established. Are they going to have a positive profit or a negative profit? Okay, so let's do that right now. The total cost that this company would experience should they decide to build this bridge, well, that was given to us in the problem setup. That was $2 million. How about revenue? How much money are they going to get if they're charging $4 per crossing? Let's figure that out. Well, to get total revenue, you're going to multiply the price that they get for each crossing by the number of crossings that actually take place. So this is going to be price times quantity, and it's therefore going to be $4 per crossing times 400 crossings. And of course, don't forget that in the very beginning of the problem, it's indicating that these quantities here are designated in thousands. So let's multiply that by 1,000. So the total revenue then for this firm, if they're doing as well as they can for themselves by charging $4 per crossing, is going to be $1,600,000. And of course, that's less significantly than the $2 million that it would cost this company to build the bridge. So you would not expect a private company to get involved and spend that $2 million to build the bridge because they're going to lose money doing so. On to question C. Question C asks, well, if we forget about a private company doing this and we have maybe the government get involved with building a bridge, what price should they charge? We're going to make an assumption here, but it's, I think, a safe one. Let's assume that the government, in analyzing this bridge situation, is trying to maximize total surplus, make the benefits to society as high as they possibly can be. And so what they're going to want to do then is to charge a price. This is part C of the problem over here, where the marginal benefit to society is equal to the marginal cost to society. Right? By doing so, we'll maximize that total surplus and have an efficient result. Okay. Well, significantly here, we know that the marginal cost for this firm is going to be 0. That's from the very beginning of the problem setup. So therefore, to get to this result, they should charge a price equal to 0. If the government were to get involved and want to maximize total surplus. Okay. It's a good point here in our analysis to point out that we're making a lot of use here of some ideas that we learned about earlier in the class. Right, so a lot of total surplus, consumer surplus, producer surplus arguments from unit number 1. So this is a good example of problems in economics that are putting together lots of different ideas. Finally then, on to the payoff here, question D asks, should this government decide to build a bridge? Again, we're going to make a small assumption here. The criteria that I'm going to rely on is that the government should do this if the benefits to society exceed the costs to society. Right? If benefits are higher than costs, go for it. If costs are higher than benefits, don't do it. So then, let's try to tease those things out from the problem here. The cost to society is given in the very beginning of the problem. This is the easy part. The costs to society is going to be that $2 million that it costs to build the bridge. What about our total benefits? Slide this over a little bit. Several different ways that you can do this, but I think it's useful to rely on some graphical analysis. So I'm going to set up here a quick little graph showing us the demand curve associated with bridge crossings here. I'm just going to plot some of the points from that table that we developed earlier in the problem. One thing to note is where the demand curve is going to cross these intercepts. Let's start with our vertical intercept up here. Right? So this would be the price that is going to give us 0 crossings of this bridge, and we can see from the table that's going to be a price of 8. So 8 is going to be our vertical intercept on the demand curve. And for our horizontal intercept, what we're asking is how many crossings will people elect to take if the price is in fact 0? You see that from the very bottom. That's going to be 800 crossings when the price is 0. So the 8 and the 800, once again, are just coming from the table that we started the problem off with. Okay. So the benefit to society then can be recognized as the area under this curve. That's going to represent the difference between the price that a person would pay and the price that they actually pay, which is 0. So let's check it out then. We can figure out the area under this curve. That'll represent the benefit to society from this particular bridge. We're almost there. Okay. So the area, which is just the area of a triangle here, a little geometry review for you. This is going to be 1/2 times the base times the height. So we're going to have 1/2 times 8 times 800. And then also, don't forget, last step here, we got to multiply this by 1,000 because all those quantities are in 1,000s. Okay, this will be total benefit associated with the bridge. Okay, calculator that bad boy right up, and you're going to find that the total benefit is equal to $3,200,000 over the lifetime of this bridge. Okay, so then that leaves us, now that we've done the hard work, with this easy comparison. $2 million to build the bridge versus $3.2 million of benefit to all those people who are using the bridge over the bridge's lifetime. And so that's definitely a go. You can argue, because of what we've just done right here, that the government should, in fact, build this bridge. All right, so there you go. Really big problem here from Chapter 15. Hopefully, you guys are understanding this. Feel free to email me with questions.